Hello everybody, welcome to this video. In this video we are going to talk about how to store float values in external EEPROM. As you know, EEPROM is a kind of storage memory that you use to store your data which you want to have after even board is powered off. Data like user password or some dates or time and etc. Some microcontrollers have internal EEPROM like Arduino and some don't like STM microcontrollers. In some cases you have too much data that you want to store them somewhere, but your microcontroller doesn't have enough EEPROM capacity, so you need to use external EEPROMs. Most of the external EEPROMs data buses are 8 bits. It means that you can store 8 bits length values in each address, or in other words, you can store values from 0 to 255 in each address. In 8 bits microcontrollers like Arduino, the size of the float variable is 4 bytes or 32 bits, and the size of an integer value is 2 bytes or 16 bits. So you need to split them to 8 bits values to store them on EEPROM. For example, you need to split a float value to 4 separated 8 bits, or an integer value to 2 separated 8 bits, and then store each 8 bits in each address. And when you want to read them, you need to read each 8 bits and then place them together to form your value. But the problem is that this procedure doesn't work for float values, and you can form your initial value by placing together these 4 bits, but it still works for integer values. Another way to store float value is to store each digit of your value in each address of EEPROM. For example, imagine that you have a value like 34.56. So if you want to store this value, you need to separate each digit and store them on each address. For example, 3 in address 0, 4 in address 1, 5 in address 2, and 6 in address 3. And the problem of this procedure is that you need to know where is the decimal point. For example, if your value is changed to 100.15, for example, the decimal point in first value was in place number 3, but in the second value the decimal point is on place number 4. So you need to remember where is the decimal point. And also there is some simplest way that I'm going to explain you in this video. Just to demonstrate the way that we split an integer value to 2 separated 8 bits, I provided a simple program in Arduino. First, we define 2 unsigned char variable in here. Unsigned char is 8 bit size in microcontrollers like Arduino, and also we define an integer value that is equal to 15, and also a variable to make to place these 2 8 bits together and make the initial value and store in this variable. So in here we start serial monitor and wait for 1 second, In here, if you use this AND operator in here and AND this integer value, which is 15, with 0 x ff, it's a 8-bit value that is equal to 255, or in binary 8 ones. So if you AND this value with this integer value, you can get 8 lowest bits of this 16-bit integer value and store it in this first variable of our array. And if you can use this equation here to take the highest 8 bits of this 16 bits integer and store it in the second variable, 8 bits variable. So in this way you can get the lowest 8 bits and the highest 8 bits of our integer value. Next we are going to place them together and form the initial value that we had, which is 15. So in here we use this statement here. If you use OR operator in here, this initial value is 0. So if you OR it with the highest value, which we calculated it in here. So if you shift 8 bits to the left and OR with this value, and also in here this is the lowest 8 bits, and OR with this variable again and store it in itself, you can get the you can form this initial value. So, and in here we print it in serial monitor, so we can see is this value is equal to our initial value or not. Let's upload our code to our Arduino and see what is the result. And upload the code, compiling, uploading, and done. So I open the serial monitor, and as you can see it shows 15, which is our initial value that we had in here, and we print the second integer that we made from the lowest 8 bits and the highest 8 bits of our initial value. So it works. In this way you can get the lowest and highest value of your 16-bit integer and store it in your external EEPROM, and then read it and place it and store it in some unsigned char variable, and use these statements to make your initial integer value. The simpler way that I'm going to explain you in this video is to use union. A union is a special data type available in C programming language that allows to store different types in the same memory location. You can define a union with many members, but only one member can contain a value at any time given. The memory occupied by a union will be large enough to hold the largest member of the union. To show you how you can use union, how to define union, and also to show you how you can store float and integer values in external EEPROM. I provided a simple program in Arduino IDE. Let's check it and see how it works. First, let's see how you can define a union. To define a union, you must use the union statement the same way as you did while defining a structure. The union statement defines a new data type with more than one member for your program. After union statement, you should give it a name, for example data, and open the bracket and close it, and also define a variable from this union in here. I defined three types of variables in here: a float type, which takes 4 bytes in microcontrollers, 4 bytes of memory, an integer type which takes 2 bytes, and an unsigned char variable which takes 1 byte. Because of the union features, all these union just take 4 bytes of memory, which is equal to the largest member of this union, and this memory location and this array memory location is shared with this float value. It takes 4 bytes, so 2 bytes is shared between this float and this integer, and also this 4 bytes is shared with this 4 bytes array. Let's assume that you are going to store a temperature value of your sensor, temperature sensor, in an external EEPROM, and also an integer number on your external EEPROM. So because your temperature is a float value, it takes 4 bytes to store it, and also because your external EEPROM data bus is 8-bit, you need to split this float value to 4 separated bytes, and also this integer value to 2 separated bytes. So to do that, I define an unsigned char array which has 4 member, 4 8-bit member. Because of the feature of union, the memory location of these float value is the same as this array. So if you want to store this float value on your external EEPROM, you just need to store these 4 member on your external EEPROM. And also, if you want to store this integer number, you just need to store first 2 members of this array on your external memory. So let's go further. As you know, the external EEPROM that I'm going to use in this video use I2C protocol for communication, so you need to first include wire library in here, and also the address of the I2C address of my external EEPROM will be 0x15 according to my address configuration. So in here we start the serial monitor and also begin the I2C bus. In here I change my temp variable to 34.56 value, So if you want to store this value, as I told you before, you need to use this array instead of this float number, because their memory location is shared and are the same. So I use this function which defined in here. I will give you the source code, so don't worry about it. So I use this function to communicate with my external EEPROM. In here I say that I want to store the first member of my array on address 0 of my EEPROM and wait for 5 milliseconds. Because the EEPROM is a slow memory, you should wait for a while for next writing or reading from EEPROM. If you don't do that, the operation will be failed and the data will not store properly. In here I say that I want to store the next member on address 1 and the next member on address 2 and the last member on address 3, and wait for another 5 milliseconds. In here I change the number variable to 2021. Be careful, in union only one member can contain a value at any given time. So if you change the number variable, the temp variable will be not to equal to this value anymore, because the location of the memory of these two variables is shared and the same. So because of this feature, if you change one of these variables, the other will change too. Since variable number is an integer variable and it takes 2 bytes of memory, so you just need to store the first 2 members of this array on your external EEPROM. So in here I stored the first one on address number 4 and the second member on address number 5. And then to form your float variable, you need to read the data that is stored on address 0, 1, 2 and 3 of your external EEPROM and store them on this array in here. So to do that, I use this function that is defined in here. So first I read the address 0 and then 1 and then 2 and then 3. So after you read this value and store them on this array, you can simply form your initial float value, by just reading this float variable, because the memory location of this array is the same as this float. The union automatically convert this array to this float number, and in here we print this float number on serial monitor. And in here, to form our integer value, we need to read the address of 4 and 5 of external EEPROM and store it on the first and the second member of our array as the same as the float number, and you can simply use the variable number to form your first integer value, which is 20, 21, and then in here we will print it on serial monitor. So let's upload the code on Arduino and check that it works fine or not. So press upload button and upload the code to your Arduino. So it's uploaded, so open the serial monitor. As you can see, the value, the float value and the integer value is the same as our initial value in here, and our code is working fine. So you can use this algorithm on your programs and projects. In this way, you don't need to know where is the decimal point of your float number. For example, let me change this float number to 150. Upload the code. And open the serial monitor. As you can see, it works fine. And also, actually, you can store negative values too. Let's check and see what's happened. Open serial monitor, and as you can see, it works fine also for negative values. So thank you for watching this video. If you want the source code, I will put the link in description of this video. So thank you for watching. If you enjoyed the video, please subscribe to my channel and like the video, and see you in next video.